The homes that are being built now are toxic. They're making us sick. They are more unhealthy for us than being outside, and it's been horrendous for the past 20 years that we think that new house smell is possibly something that we want to emulate. And there's so much trash. We're just used to seeing this when we see homes being built, just having all of this debris sitting outside. There's more trash that comes from construction sites than any other thing in the US. It's crazy. And it can be so much better. And so I'm quite thankful that we have the housing crisis, because now it puts everyone, sends them back to the drafting board, sends them back to reimagine what our homes can be. And the work that I've been doing for the past 8 years has been trying to reimagine the home and making thoughtful, sustainable design accessible for people, having clean design, having simple design, creating homes that have more and less, rather than continuing to buy into the idea that bigger is better, but really better is better, and looking for double function wherever we can, because as smaller homes and wanting more and less, we want more out of each object. So like this island that I designed that's /island/dining table, and it can be used for both. Looking for opportunities in all areas, in the roofs, making them inhabitable, making them produce food, and thinking about how we can design homes so that we don't have to turn on lights during the day, which is not about putting in a lot of windows, but having them be very strategically placed, where we wash ceilings with light and balance it with washing the floor with light, where we use windows on the kitchen countertops to wash the countertop with light, which is where we want the light. Having light in all rooms, like in the bathroom, but still having privacy. Sculpting light in, down, through vertical spaces wherever possible. Having these high windows also allows us to have the hot air go up and out. And with windows then, proper sun shading. These are all things that don't cost anything more, but really help us. And having these louver systems that can adjust so it allows the wintertime warmth, the sunlight from the winter sun coming in, but go horizontal during the summer when we don't want it. Having sun shading for this house that we designed in Napa, where we actually bring the vines into the house to actually provide the sun shading. Using really efficient heating systems, LED lighting systems, looking to, in Europe, they've been working on passive house standards, using things like heat recirculating systems, and making the homes so that way they are net zero energy. And our house, this is my house, it actually produces twice as much energy as the home actually needs. Using 1/3 the water just by making smart choices in the faucets, using gray water systems, rainwater catchment systems, making the rainwater catchment systems into water features. Here we have a reflecting pool that filters the rainwater and then uses it for irrigating the landscape. Choosing landscape that doesn't require water, and also looking to new wall systems that will actually absorb condensation and help collect that water. Making homes that are smart. This is a photo of the smart home that's here at the Museum of Science and Industry that we designed, and it's currently an exhibit that you can go through. And we tricked it out with all kinds of really cool things, like these automation systems where with the push of a button on a hot afternoon, the shades will go down, the skylights will open up, and the hot air will leave. So it's using technology that has been around for a long time, but mainly it's been used for the bachelor pad of, like, you know, press the button and the lights go down and the music comes on. But it's using it for good. And this is something that then can hook to your phone. So if you are at the studio and it's a hot afternoon, with the push of a button, you can have at your home, the shades go down, the skylights go up, and the hot air go up and out. Here we have a countertop that allows the appliances to sit on top and not have to be plugged in to the wall in order for it to be powered. This actually uses less energy with the direct electrical connection. And then having homes actually give us information, because this is what's really powerful. For any of us who drive the Priuses, we can see when we have the dashboard and we have the information to show us how our behavior translates into energy usage. It's really helpful, and I think people sometimes ask me if I could do one thing in every home, what would it be? And I think it would be this, that it really helps us to still have great lives, but use less energy and use less water. Also, as we reimagine the home, thinking about them as being food producers, actually producing local food on your roof, in your courtyard spaces. Using eco-materials, of course, here we have the poster child of eco-materials, bamboo, but many are coming on the market now that recycle materials. Here we have FSC certified cabinetry, countertops made from sawdust from construction sites, recycled plastics, recycled glass. Here on the left image, those are glass tiles made from Chardonnay bottles. On the right side, they're tiles made from soda bottles crushed into concrete. And really thinking about health. I think health in our homes and health in construction has been the kind of forgotten part of sustainable design, and it's so important. Looking at materials that don't off-gas, that have no new house smell, no smell. Looking to alternatives for wood-burning fire, looking to alcohol and to gas. And also choosing materials and design that are going to last a long time. So we look to materials like Corten steel that won't ever have to be painted, won't have to be replaced. Looking to concrete cement boards that have integral color, so that way there won't have to be maintenance. And so with this reimagining of the home, the critical part to make it accessible is it can't take any more time than a non-green home. It can't cost any more than a non-green home. And it needs to be easy. And if we, as designers, can achieve those three things, then we make it possible for everyone to have a green home. And the way that I've been working on trying to think about this puzzle is through thinking about the way we construct homes, looking to systems building. So on this slide, prefabrication, which is this overriding umbrella of really anything that is built off-site in some way and shipped to a site. In doing it, we actually can have much less time because the home is being built in the factory while the site work is happening, versus the typical way that things happen is you have to do the site work and then you do the home. Plus it's built on an assembly line. So with this home, the smart home, I'm just going to show the setting of this home. It was built in the factory for 2 months. Then it arrived as 7 modules, 7 pieces, 2 for the garage and 5 for the home. And when these modules arrived, it's kind of hard to tell from the video, but all of the furnishing, all of the materials are inside. The flooring is in, the cabinetry is in, the towel bar holders, the toilets. So the house started being set at about 7:30 in the morning, and by 4:30 that day, I was walking through the house doing the punch list. And that is so exciting, because normally, as an architect, you might go to a project every week and you have to kind of look for the progress. So this is nothing short of thrilling. Then after the set day, then it takes approximately 2 months in this case to do what we call the button-up work, which is attaching the modules to one another. Here we're doing the green roof, the roof decking, solar. Probably half the time we'll do solar in the factory. Here we did it on site. Doing the decking, the landscaping, and then the home is complete and you can move into it. So it's making it much easier, making it more accessible for people then to have a green home. Because of how it's built in the factory, it's actually stronger than a site-built home because everything has to be nailed and screwed per site-built code, but in addition to that, it's also glued because the modules have all the finishings in them before it gets shipped, and it goes through the worst earthquake of its life before it even gets to the site. So we have to do it really strong. Plus, there's 50 to 75% less waste because of the precision cutting and there's storage capacity versus the contractor who's on site just doesn't have the space to store the material. So it all ends up in the trash bin, and the overflowing trash bin. And with that, then, there are cost efficiencies. And many times it will actually cost less to build this way than cost more. And then with all of this, looking at how we can make the information more transparent, how we can begin to make it easier for people to make smart choices when they're looking at homes. And it's sort of like we need nutrition labels for homes where it actually will show in a very easy to understand way what the house is made of, where's the fat, how good is it going to be for us, how healthy is it going to be. And with this kind of offsite technology, this idea of trying to make good design for the masses when it comes to the home, This is the most critical issue, is this scale issue, because in order to truly have the cost efficiencies that makes it really accessible and the time efficiencies, it requires doing homes in volume, doing big scale. But in order to do them in big volume, you need a lot of orders, and so therefore you need to have the cost efficiencies and the time efficiencies, and it becomes this very difficult cycle of the chicken and the egg of how to make that happen. And so one of the ways that I'm now working on trying to crack that nut is working on multifamily projects. And this is when we can actually have the scale to get the numbers to be very interesting. This is a community that I'm working on in Denver, where we built the first 8 homes and built them in the factory, built them for less money and less time than had they been built on site. The project produces more energy than it uses. And then the next phase will be 12 homes. In total, it'll be 106 homes. So again, we're working on phasing it. Also looking at disaster relief housing. This is where green prefab makes so much sense, that rather than doing the FEMA trailers and giving people unhealthy, not lasting temporary homes that end up becoming permanent and make them sick, using this technology as a way to give them permanent, wonderful homes that can be built quickly and can be deployed quickly. And then lastly, looking to how we can integrate information technology to help with this as well, because one of the trickiest parts has been the modular portion. The part that's built in the factory is very predictable and can be very effective to do it. But every site is completely different. And with that is not only the actual topography of the site, but every site then has slightly different nuances with the codes and with the fire marshal, and with the climate and where the views are. And so it becomes very difficult to scale that. And obviously, we don't want to just pump out a bunch of homes that have nothing to do with the site. That doesn't make any sense. We need it to really work with the sun, work with the breezes, work with the views. But that's time consuming. So overlaying certain maps, the GIS maps, where we start to gather that information and aggregate that information, I think is very interesting. And lastly, I'll leave with this, which I think was the best thing that I have learned in the past year since having to close my previous company, which is, I hate to admit this, but I used to really look at people in a very competitive way. And now that has completely changed, and I look at everyone as potential collaborators. And that has made this past year one of the best ones of my life. And so I'm thankful for the failure, and I'm excited for what it can mean. Thank you.